everyone. Today I'm going to go through with you Redox again, but now this time is in a different way, okay? So let's see whether you understand this, especially with my face. Alright. Okay, so let's begin this. I'll place this here, I'll hide this. Alright, so you have already gone through the first lesson of Redox. Alright, so you would have an idea of what Redox is. So let's do a quick recap, okay, of the main concepts. Firstly, oxidation. In a reaction, oxidation is considered to have happened if there is an addition of oxygen or something loses hydrogen, there is an increase in oxidation number of the substance, or you see a loss of electrons. That means something becomes more positive. That's how you lose electrons, right? And reduction is practically the opposite, which means you see a loss of oxygen in a substance, you see an addition of hydrogen in a substance, or you see a decrease in oxidation number and the gain of electrons, which means it will be becoming a negative ion. Okay, so it gains electrons. Okay, so let's move on to each one of these segments and we will elaborate this further. If you didn't understand from the previous SLS lesson, hopefully this will give you a little bit more of a clarity. Okay, so first one, oxidation is addition of oxygen. Reduction is the loss of oxygen. So we're talking in terms of oxygen now. So in a reaction, if a reactant gains oxygen, that means it has been oxidized. Okay, so you're going to look for a reactant that gains oxygen. And then it forms a different substance. Okay, so that means it is oxidized. Now in the same reaction, or in a reaction generally, if again a reactant, okay, you see the word reactant, that means you have to look at the left hand side of the chemical equation. If a reactant loses oxygen, that means it is reduced. All right, so let's look at this equation. Carbon plus oxygen gives you carbon dioxide. Quite straightforward. From here you can see a clear oxidation. Carbon at first has no oxygen, but after the reaction, carbon has formed carbon dioxide. It has gained 2 oxygens. So in this case, carbon, which is the reactant, has been oxidized to form carbon dioxide. So carbon has gained 2 oxygen atoms to become carbon dioxide, and therefore it is oxidized. All right. So now one more thing about redox reaction is when you see something is getting oxidized, the other reactant is actually getting reduced. So in this case, oxygen actually has been reduced because carbon is oxidized. So we understand that the other reactant, which is oxygen, is reduced. But you can't explain the reduction of oxygen in terms of gain or loss of oxygen, because oxygen here is O2, over here is still O2, right? However, if you do some calculations, you'll find out that this oxidation number of the oxygen has changed from 0 to -2. This one, we will talk about it in the addition, or sorry, increase or decrease in oxidation part of the session, okay? All right. Another example of addition and loss of oxygen. Now, in this reaction, you can see both. One will gain oxygen, the other one will lose oxygen. By just looking at this equation, are you able to figure out which is which? Here, I give you 5 seconds. Okay, my first error has already come up. So you can see zinc has become zinc oxide. So it has gained oxygen. And copper 2 oxide, CuO, has become copper. It has lost oxygen. Okay, so zinc is oxidized because it has gained an oxygen. And copper 2 oxide is reduced. It has lost the oxygen. So you see, every time I say what is oxidized or what is reduced, I'm always referring to the reactants. I'm not referring to the products. I don't say zinc oxide is oxidized. No, it is zinc that has been oxidized to become zinc oxide. Okay, the same. Copper 2 oxide has been reduced to become copper. All right. Okay, now moving on, let's look at the loss and addition of hydrogen. So oxidation has happened if a reactant loses hydrogen. Okay, and reduction has happened if a reactant gains hydrogen. So this is the part that I see some of you are getting mixed up in your SLS lesson. you think that if it gains oxygen, it's oxidation because of the word gain. Okay, but do take note, for oxygen and electrons, it is loss for it to be oxidized. Okay, loss of hydrogen, loss of electrons will be oxidation. All right. So now let's look at this equation. So in this equation, again, you see nitrogen has no hydrogen here, but ammonia has nitrogen has gained 3 hydrogen. So in this case, you can see that nitrogen has gained 3 hydrogens in the process. So that means nitrogen has been reduced because it has gained hydrogen. Okay, so nitrogen has gained 3 hydrogen atoms to become ammonia. Now again in this process, because nitrogen is reduced, the other reactant, which is hydrogen, will be oxidized. But again, we can't explain it in terms of addition or loss of hydrogen, because over here you see H2 then suddenly become H3, right? Looks like it has gained hydrogen also. But that's not the case here. Actually, what has happened is the oxidation number of hydrogen has gone from 0 to +1. So it has been oxidized. Okay, so this one again we will cover in the next few slides when we talk about increase and decrease in oxidation number. Okay, so talking about increase and decrease in oxidation number, oxidation means increase in oxidation number, reduction means decrease in oxidation number. So one example is this: a metal becomes an ion, right? A positive ion. So the initial charge of the metal is actually 0. It has 0 charge. But when it becomes an ion, it becomes a plus, a 2 plus, a 3 plus. So like Na plus, Ca2 plus, aluminium is Al3 plus, right? So how does that happen? It's because it has been oxidized. Okay, so metals are oxidized to become metal ions. Okay, and metal ions are also known as cations. Now, the opposite is for reduction. Okay, so for reduction, you can see a non-metal will become a negative ion, right? So again, the initial charge of the non-metal in its natural form is 0. But when it becomes an ion, it gets a charge of a minus, right? Or 2 minus or a 3 minus, like Cl minus. Okay, this one wait first. Cl minus, O2 minus, what is 3 minus? N 3 minus, right? So in this case, you can see that it has gone from 0 to a minus number, so it has been reduced. Okay, so it has a decrease in oxidation number. All right, and it has become a non-metal ion. It's supposed to be anion, not cation. This one is wrong. Okay, anion. Okay, I'm going to move this here so that you can see the table below. So now this table is showing us some general rules about these oxidation numbers. Okay, any free elements in their natural form will have an oxidation number of 0. So what are free elements? Things like metals. Whatever metals you see in the periodic table, if you're using them as they are in the chemical equation, those are free elements. Okay, so those will have a charge of 0. Diatomic elements, for example, chlorine, hydrogen, fluorine, okay, I've listed a few here. These will also have a charge of 0. Okay, so that is their initial charge. O2 has a charge of 0. N2 has a charge of 0. Okay, their overall charge is 0. Now, other examples would be iron. In their ionic form, you can have Fe2 plus and Fe3 plus, right? So Fe2 plus oxidation number is +2, Fe3 plus oxidation number is +3. So you just follow the charge. But instead of writing the sign behind, you write the sign in front. Okay. Oxide, usually oxide, if you see an O in a substance, other than O2, O2 is a free element. Okay. If you see an O in a substance, for example, CuO, copper 2 oxide, the O has a charge of a 2 minus, usually. All right. So its oxidation number is -2. The same for hydrogen. Whenever you see hydrogen, especially if it's at the front, it's the start of a chemical formula, it is usually a charge of a plus, which means its oxidation number is a +1. Okay. Finally, compounds. When you see compounds like this, their overall charge is 0. So the oxidation number of the whole compound is 0. But each of these elements will have their own individual charges, which will add up to become 0. Okay, so in the next slide, I'm going to show you this thing about compounds, how their oxidation number of the whole compound is 0, but each element has its own charge. Okay, so look at these 3 boxes. We're going to do one by one. First one is sodium chloride. So overall oxidation state is 0. Sodium chloride, this one is 0. Why? Because sodium has a charge of +1. Chlorine has a charge of -1. So plus 1 minus 1 gives you 0. All right. Now, if you look at calcium nitrate, calcium has a charge of +2. Nitrate has a charge of minus, but because there is two of them, so it's -1, which is -2. Again, when you add them up, you will get 0. Okay, but individually, they have their own charge. Last one, water. Hydrogen, 2 hydrogen, so it's 2 and H plus. So it will be +2. Oxide is a 2 minus, so it will be a -2. So when you add them together, you get a charge of 0. So in this case, if I ask you the charge of the whole compound, it is 0. But if I ask you for the charge of sodium in NaCl, then it will be +1. Okay, the charge of sodium in NaCl will be +1. The charge of a nitrate in calcium nitrate is a -1, for example. Okay. The next one is oxidation states again, but now of ions. Okay, what's so special about ions? If you look at ions, ions will already come with a charge. Okay, which means their total oxidation number is this that is given here, -2, for example. So sulfur, we may not know. Oxide, like what I told you, most of the time, usually it's a 2 minus. However, if you notice, there are 4 oxygen here, which means there are 4 oxides. Okay, so in a while, I'm going to talk to you about that. The total oxidation state is actually a -2 because it's stated here -2. So you just bring this over, -2. Okay, so oxide is a -2. But because there is 4 of them, so it's 4 times -2, which is actually a total of -8. All right, so now you need to form an equation. What equation are you going to form? You need to form an equation that shows you -8 plus whatever S is going to give you -2. Okay, and if you do the equation correctly, you should be able to find out what is the charge of S, okay, and that would be a +6. My stylus is currently not working, so I can't show it to you there. Let me try to use a pen, see if I can write it. Okay, so how would your equation look like? It will be S plus 4 times -2. Okay, equals to -2. Okay, so if you solve this, you should be able to find out what is S. S will be a +6. All right, so you see, I've indicated the plus also. I don't remove the plus sign, just keep it there together with it. Okay, you're going to see the same pattern. You can do this calculation on your own for the rest of them. Okay, so S would have a charge of S6 plus. Okay, so nitrate, again, ECI has a charge of a minus, right? That means its total oxidation state is -1. Okay, so we don't know N, for example. We know O is a 2 minus most of the time. Total oxidation state is -1 from here, right? -1. So oxygen, we assume that it's going to be a -2 usually. And how many oxygen is there? There are 3 oxygens, so times 3. So -2 times 3, you get -6. So now you think of this one, -6, -1, right? So if you're going to do a equation to solve, you can solve for N, and you will get a +5. So the oxidation state of N in nitrate is actually +5. It's not -3, like how we always know, right? It's in group 5, so it should be -3. But that's not the case here. Okay. Okay, hydroxide, quite straightforward. Okay, hydroxide, we know hydrogen is a H plus. We know oxygen is a 2 minus, right? Usually. So let's just keep them as they are, H plus and 2 minus. So if you have +1 -2, then your oxidation number is going to be minus. So that's why oxide has a charge of minus. All right, so this is how you calculate the oxidation number of the substances or particular elements in compounds or ions. All right. Okay, so now in this part, I'm going to show you how metals become metal ions, non-metals become non-metal ions. Okay, so metals, as I said, is free element, right? So it's going to be a charge of 0. And when it becomes a sodium ion, it's going to have a charge of +1. So what has happened to it? Has it been oxidized or reduced? So in this case, there is an increase in oxidation number. So it has been oxidized. All right. Now let's look at chlorine. Okay, chlorine gas, for it to become a chloride ion, it needs to gain electrons, right? So that's why this plus 2e is over here. When it gains electrons, it becomes a Cl minus ion, which is a -1 charge. So at first it's a free element, is 0. But after it becomes an ion, it becomes -1. Right? So you can see from 0 to -1, there's a decrease in oxidation number. Okay? So in this case, it has been reduced. You can combine these two together and you'll get sodium plus chlorine. Something's wrong with the chemical formula equation again. Sodium plus chlorine gives you sodium chloride. Okay? So now when you look at this, I'm going to combine both together. This has become, sodium has become from 0 to +1, has been oxidized. Chlorine, the other reactant, 0 to -1 has been reduced. Okay, so sodium has increased in oxidation number from 0 to 1 to form NaCl. Chlorine has decreased in oxidation number from 0 to -1 to form NaCl. All right. So while sodium is oxidized, chlorine is reduced. You can see both redox, oxidation and reduction, happens in the same equation all the time. Okay, moving on. Okay, the last factor, gain and loss of electrons. I'm going to use the same example as I did in the oxidation number 1. Okay, because to gain or lose oxidation number, you need to gain or lose electrons. All right. So in this case, where is my cursor? Okay, in this case, if a metal loses electrons, it becomes an ion, correct? It loses electrons in the outermost shell. When a non-metal gains electrons, it will become an ion. All right. So you already know this from your chemical bonding. So how is it going to work for oxidation and reduction? So a metal, it loses its electron, so the electron come out, and then it becomes a Na+. Okay, so each sodium lose 1 electron to become an Na+ ion. Now for chlorine, it has to gain the electron. So whatever that is lost over here is going to be gained over here, right? So it gains these 2 electrons and then it becomes Cl- ion. Okay, so this is how you explain oxidation of sodium to become Na+ by in terms of the loss of electrons, and reduction of chlorine to become Cl- in terms of electrons. Okay, the gain of electrons. So if you have the same equation again, sodium is oxidized, but this time look at the explanation, is different. I didn't talk about the gain or loss in oxidation number. Instead, I talk about the gain or loss of electrons. Sodium in the metal lost 1 electron to form Na+. Chlorine in chlorine gas has gained 1 electron to form Cl-. Okay, so I'm talking about the same thing, oxidation and reduction. But the first one just now was in terms of oxidation number, and this one is in terms of the loss or gain of electrons. So sometimes the question will ask you to specifically describe the reaction based on one of the factors. So then you have to use those to explain. They might say, explain this chemical equation in terms of gain and loss of electrons. Then you must use the electrons way to explain. All right. Okay, so one practice question here. Determine the oxidation number of elements in each of the following substances. These are the first 2 questions, I think, if I'm not wrong, in the practice question that I've given you. So H2CO3. Now this is a compound. So you need to find the oxidation number of each of the elements here. So let's look at some general rules. The total oxidation number of the whole compound must be 0. Okay, so in this case, the whole thing equals to 0. Now we also know hydrogen usually is a +1. Every oxygen is a -2. Okay, so these are the rules we're going to apply to do the question. Total oxidation state is 0. Every H is a +1. Every O is a -2. So now we're only left with carbon to find out. So we form a simple equation to find out carbon. Okay, so there are 2 hydrogens, so it's 2 times +1 plus carbon, we don't know what is carbon, plus 3 times oxygen -2, gives us 0. So if we solve for carbon, you'll get carbon is equal to 6 minus 2, which is a plus 4. All right. Therefore, oxidation numbers of hydrogen is a plus 1, oxygen is minus 2, and each carbon is a plus 4. All right. Now, second example. Now, you see this one has already a charge. That means oxidation state is not 0 anymore. Oxidation state is minus 2. Okay. So, total oxidation state is a 2 minus, minus 2. Why? Because it's 2 minus, so the charge, you must bring it over as the total oxidation state. Okay. So, again, the same thing. Hydrogen is a plus 1. Oxygen is a minus 2. We just take it as it is. Okay. So, now we try to solve for zinc. What is the oxidation number of zinc? We form a simple equation. So, zinc plus 4 times minus 2 plus 1, because minus 2 is oxygen plus 1 is hydrogen, and you need 4 of them, is equals to minus 2. So if you solve this, zinc will be equals to plus 4 minus 2. When you simplify, you'll get plus 2. So the oxidation number of zinc is a plus 2. Oxidation number of hydrogen is plus 1. Oxygen is minus 2. Zinc is plus 2. All right. Now note this. I don't drop the plus sign. Okay, I keep the plus sign, because for oxidation number, you really need to write whether it's a plus or minus. So if it's a plus, your general tendency is not to write the plus sign. Okay, so please be very careful. Make sure you write the plus sign. So you see for both, I've written the plus sign. Okay. Okay, coming to the almost the end already. Okay, oxidizing and reducing agents. Okay, we know that in every chemical reaction, there will be something that is oxidized, something that is reduced, right? Reactant 1, if it gets oxidized, reactant 2 is going to get reduced. Now, they are going to be oxidizing and reducing agents for each other. Okay, how is that going to work? First, an oxidizing agent causes the substance that they are reacting with to become oxidized. So that's why it's called an oxidizing agent. It oxidizes its partner. A reducing agent will then reduce its partner. Okay, so let's look at the chlorine and the sodium example again. We can see sodium is oxidized and chlorine is reduced, right? So in this case, which is the oxidizing agent? If sodium is oxidized, that means it was oxidized by what? It was oxidized by chlorine, right? So chlorine is then the oxidizing agent. Now chlorine is reduced. But what has caused chlorine to reduce? It is the sodium. So sodium is the reducing agent. Okay. So now what else do you note? What happens to the oxidizing agent? The oxidizing agent is getting reduced. And what happens to the reducing agent? Reducing agent is getting oxidized. Okay, sodium is the reducing agent, right? But sodium is getting oxidized. Chlorine is the oxidizing agent, but chlorine is getting reduced. Okay, so in the process, while they oxidize something else, they themselves will reduce. While they reduce something else, they themselves will be oxidized. Okay, so that's the general understanding of oxidizing and reducing agent. Now, in every redox reactions, you can find out which is the oxidizing agent, which is the reducing agent. Okay, everything. Every single redox reaction, you can find that. However, there are some common oxidizing and reducing agents that we always will use. Okay, so this will always appear in your work also, so you can take note of that. So the common oxidizing agents are all these: bromine, chlorine, concentrated sulfuric acid, not dilute, concentrated sulfuric acid, nitric acid, oxygen, potassium manganate, potassium dichromate, and hydrogen peroxide. All right, common reducing agents will be carbon, carbon monoxide, hydrogen, hydrogen sulfide, metals, potassium iodide, sulfur dioxide. Any more? Yes, ammonia. Okay, do you need to fully memorize this? Maybe. But some of them you will remember automatically because it will appear in your practicals and things like that. But what's more important, right, is for you to identify them based on the chemical reaction that's given to you. So if you're able to do that, then you don't need to memorize this per se. Okay, so let's try. Okay, so these are the common oxidizing and reducing agents. Okay, one more way for you to identify this. Okay, one more way for you to identify this is oxidizing agents, right? They will get reduced in the process of oxidation. They are going to oxidize something else, so they're going to get reduced. So in that case, their color intensity will become lighter because they're getting reduced. All right, this is important for colored oxidizing agents. Okay, so the colored oxidizing agents are potassium manganate, which is originally purple. So when it's oxidizing something else, it's going to get reduced. It will actually turn colorless. The other one is potassium dichromate. We don't use it in the labs anymore. However, it is orange in color. So when it is oxidizing something else, it will get reduced. So it will turn from orange to green, a lesser intense color. All right. So the opposite is true for reducing agents. For reducing agents, because they are reducing agents, that means they themselves are going to get oxidized. So when they are oxidized, their color will intensify. One example from here is potassium iodide. Potassium iodide is colorless to start with. But if it is going to reduce something, right? It will be then oxidized, right? Which means it will turn from colorless to brown. Okay? So remember, for a reducing agent to react, it will be oxidized, which means there is an oxidizing agent present, right? So potassium iodide in the lab is actually used to detect oxidizing agents. And potassium manganate is actually used to detect for reducing agents. So if a reducing agent is present, if you add potassium manganate, it will turn from purple to colorless. If an oxidizing agent is present, if you add potassium iodide, it will turn brown from colorless. All right. That's what's explained in the next one. So in science practicals, these are the ones that we will always use. Let me just go through them one by one. So potassium manganate is usually added to test for reducing agents. You want to know whether substance X is a reducing agent, you will add potassium manganate. Okay, and if potassium manganate turns from purple to colorless, then you can confirm, yes, substance X is a reducing agent. It has reduced potassium manganate from purple to colorless. Another one is hydrogen peroxide. It's usually added to substance to oxidize oxide ions. So when oxide ions in a substance is oxidized, it will then form oxygen gas. So once you see the word oxygen gas, so what you need to do? You need to test for oxygen. So the moment you see hydrogen peroxide in your experiment, be ready to test for oxygen gas. All right. So now common reducing agents will be metals, potassium iodide, and sulfur dioxide. For metals, usually it's added to acid. Okay, what does it do? It actually reduces hydrogen ions, H plus, to become hydrogen gas, which has a charge of 0. So from +1 to 0, right? So that is metals. Okay, potassium iodide, it is added to test for oxidizing agents. So if you add potassium iodide to substance X and it turns from colorless to brown, then you can confirm that substance X is an oxidizing agent. That's why I was able to oxidize potassium iodide. All right, so the color change is colorless to brown. That's why I put the box as brown lah. Okay, if you are a visual person, maybe these colors can help you to remember them. Finally, sulfur dioxide. To test for sulfur dioxide, we actually use potassium manganate, right? Purple, and then we put on the filter paper, and then we put the filter paper on the mouth of the test tube. And if it turns from purple to colorless, it will turn brown first, and then yellow, then colorless. Then you can confirm the sulfur dioxide gas is present. Okay, that's because sulfur dioxide is a reducing agent. It's going to reduce potassium manganate to become something else. All right. Okay, final slides already. Important points for you to remember in redox. Okay, this is a summary of whatever we've went through so far. First, oxidation and reduction will happen in the same reaction. All right. And in the same equation, you'll be able to find out which reactant is oxidized, which reactant is reduced. And the reactant that is oxidized is the reducing agent. The reactant that is reduced is the oxidizing agent. All right. Neutralization and precipitation are not redox reactions. So if you're given acid plus base, acid plus alkali, right, you can definitely cancel that out. It's not a redox reaction. The same for precipitation. Okay. When a substance is oxidized, its color can intensify. So colorless to brown, that's one example for potassium iodide. When a substance is reduced, its color will lighten. So from purple to colorless or from orange to green. Okay, these are not all the time. Okay, but these are good indicators of oxidation and reductions happening. Finally, oxidizing agents will oxidize the other reactant but will get reduced in the process. And reducing agents will reduce the other reactant but will get oxidized in the process. So remember these sentences well, okay, for you to identify oxidizing and reducing agents. Okay,